Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 8 of unit current electricity. In today's class we are going to discuss about the electric cell. It is part 2 of a electric cell. In the previous classes we have done the charging and discharging of a cell. I want to revise this quickly and then we will move to the question answers. When it is a charging of a cell, we say V is equals to E plus IR, where V is the terminal voltage, E is the EMF, I is the current passing through the cell, and R is the internal resistance. When we say its cell is being discharged, that means a discharging of cell, we can say V is equals to E minus of IR. That means terminal voltage is less than the EMF of a cell. This is the charging and discharging. Now when cells are connected in series, something like this, it's an ER, 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 E comma R. Let's say E1, E2, E3, E4, E5. Then E net can be written as E1 plus E2 plus E3 up to En, and R net can be written as R1 plus R2 plus R3 up to Rn. This is the series combination of a cell. This is the series combination, and when the cells are connected in parallel, something like this, then E equivalent, let's say this is E1 comma R1, this is E2 comma R2, this is En comma Rn. Then E equivalent can be written as E1 by R1 plus E2 by R2 up to En by Rn, divide by 1 by R1 plus 1 by R2 up to 1 by Rn, and 1 by R equivalent can be written as 1 by R1 plus 1 by R2 up to 1 by Rn. This is what we have discussed in the previous class about the electric cell. I hope you remember this. Did you? Great. So now let's look at the questions. But before you start doing your questions, have your pen, have your paper, and start doing it with myself. Yes, we are going to check the answer at the end of the question. So let's begin then. Do it quickly. When two identical, when they say identical, that means their EMF is same as well as their internal resistors are same. So when two identical cells are connected either in series or in parallel across a 4 ohm resistance, they send the same current through it. Internal resistance of cell is required. So the situation is something like this. It's an E comma R, E comma R, and they are connected in series with a resistance of 4 ohm. So in this situation current should be I is equals to 2E divided by 2R plus external resistance, which is a 4 ohm. And when this is connected in parallel, it look like something like this. It's a first cell, it's a second cell, and this is the 4 ohm resistance. So their E equivalent could be written as E1 R2 plus E2 R1 divided by R1 plus R2. This is R2, sorry, it's a E versus R, E and R. So this is equals to ER plus ER, this is 2ER divided by R1 plus R2, which is a 2R. This is E equivalent, and this is equals to E only. Now I is equals to E equivalent divided by R equivalent, it is an R by 2 plus 4, and this E equivalent is E itself. So what I have, it's an I is equals to E divided by R by 2 plus 4. This is when they are connected in series. This is the case when they are connected in parallel. As our data says that current is same whether they are connected in series or whether they are connected in parallel. So I can equate this, that Is can be equals to Ip, and Is can be written as 2E divided by 2R plus 4, and this is equals to E divided by R by 2 plus 4. So this E can be cancelled out, and this is 2 divided by 2R plus 4 should be is equals to 2 divided by R plus 8. So this 2 can be cancelled out, and what I can have, it's an R plus 8. This is equals to 2R plus 4. So this 2R minus of R can be written as 8 minus of 4. So this 2R minus R, which is R, this is 8 minus 4, which is a 4 ohm. So my internal resistance of this cell would be 4 ohm. I hope you got this answer. Yes? Did you get this same answer? Did you? Great. Do you understand this? Any doubts? Anything? No? Great. Let's look at this question. The potential difference across the terminal of a battery is 50 volt when 6 ampere of current is drawn, and potential difference is 60 volt when 1 ampere is drawn. The EMF and internal resistance of the battery is, okay, so I know that when it is discharging, I can write like this, it is V is equals to E minus IR. Now voltage is 50. Voltage is 50 when current that is of 6 ampere is flowing. So 50 is equals to E minus 6 into R. This could be my first relation. And potential difference is 60 volt. This is 60 is equals to E minus current is 1 into R. This is my second relation. So I am having two relations. 50 is equals to E minus 6R and 60 is equals to E minus of 1R. So let's just try to solve this. This is 50 is equals to E minus of 6R and 60 is equals to E minus of R. This is relation number 1. This is relation number 2. So minus plus. So this E and E has been gone. 50 minus 60, this is minus of 10, should be is equals to minus of 6R plus R. It's a minus of 5 into R, and when minus of 5R, minus plus, and the R is equals to 10 divided by 5, which is of 2 ohm resistance. Yes, so I found one thing, it's an internal resistance of the cell, and let's put it up this value in any one of the relation. It's a 50 is equals to E minus 6 into 2. So this is equals to E minus of 12 equals to 50, and this E is equals to 50 plus 12, which is of 62 volt. I hope even this is your answer. 62 volt and 2 ohm. This is the answer. Did you get the same thing? Did you? Yes. Was it easy? Beat easier. Yes. Let's look at the next question. Do it quickly. When a resistance of 2 ohm is connected across the terminals of a battery, a current of 2 ampere is found to flow. When a second resistance of 8 ohm is connected in series with the first, the current is reduced to 1 ampere. The EMF and internal resistance of the battery is, yes, this is might be the situation. This is E, this is R, and in a first situation, resistance of 2 ohm has been connected to the terminals of a battery, and the current was of 2 ampere. Now what the situation is when a second resistor is connected? This is the situation. This is E, this is R, and this with this 2 ohm, one more resistance which is of 8 ohm is being connected. This is 2, this is 8, and now the current is, this is I is equals to, or I can say I dash is equals to E divided by 2 plus 8. This is 10 plus R, and in first situation the I was E divided by R plus 2. Initially current was 2 ampere. So what I can have, it's a 2 is equals to E divided by R plus 2, and here the current is found to be 1 ampere only, so 1 is equals to E divided by 10 plus R. Yes, this is relation number 1. This is relation number 2. So let's just try to solve it. It is something like this. 2 is equals to E divided by R plus 2. That means E is equals to 2R plus 4, and 1 is equals to E divided by 10 plus R. That means E is equals to 10 plus R. This is the situation. So this is relation number 1. Relation number 2. So this is E is equals to R plus 10. Relation number 2. Let's just solve it. This. It's a E and E has been cancelled. This is 0. 2R minus R. It's an R. 4 minus 10. It's a minus of 6. So this is equals to R is equals to 6 ohm. So I got this internal resistance. What else is required? It's an EMF of the cell. EMF can be calculated as E is equals to R plus 10. R is of 6. 10 here. It's a 16 volt. This is E. Yes. Almost same kind of question. Almost same kind of question has been asked. Now let's look at this question and do it quickly. A cell of internal resistance 0.5 ohm and EMF of 2 volt is connected to a resistance of 9.5 ohm. The potential difference across the cell is, we need to find out the potential difference. How can we do this? How can it be done? Yes. So this is the situation. V is equals to E minus of I into R, and I don't know current, so I can replace it with I is equals to E divided by R plus R. So I want to find out the V. Is equals to E minus of E divided by R plus R multiplied by R. So it seems something like this. E as a common, that is 1 minus of R divided by R plus R. Now let's put up the value. EMF, it is of 2 volt. This is 1 minus internal resistance. What is it? It's a 0.5 ohm. Divide by. This is 9.5. This is 0.5. So this is 9.5 plus 0.5. It's a 10. Yes. So this is equals to, this V is equals to 2 into bracket 1 minus 0.5 by 10, that is of 1 by 20. This is equals to 20 minus 1. It's a 19 by 20, and this is 2 tens. So 19 by 10, which is 1.9 volt. This is the situation. Is it clear? Is it? So can you do this kind of questions? Are you sure? Can it be done? Can it be done? Great. Let's have a look to the next question. What does it say? It says a battery has 6 cells in series, and each cell has an EMF of 1.5 volt and internal resistance of 1 ohm. Okay. If an external load of 24 ohm is connected to it, the potential drop across the load, you need to find out the potential drop across the load. So the situation is something like this. First, second, third, fourth, fifth, and sixth. These are the identical cells. Each one is of 1.5 volt and 1 ohm. This all cells are the same, and this is connected with a battery. This is connected with an external load, of 24 ohm, and I need to find out potential difference. I need to find out potential difference across this load. This is my requirement. So how can I do this? So first, what I can do is that let me calculate the current flowing through this circuit. So current is I is equals to, there are 6 cells each of 1.5 volts. So source supply, it's a 1.5 multiplied by 6 divide by R internal plus R external. So 1.5 plus 6, it's a 9, divide by internal resistance. There are 6 internal resistance, each is of 1 ohm. So this is 6 plus 6 plus R external. R external, it is of 24 ohm. So this is 9 divided by 30 ampere. This is the current. I is equals to 9 divided by 30 ampere. This is the current that is flowing through the circuit. So this is current. Now what I want, this is the situation. 24 ohm, and I need to calculate potential difference across this. It's a 24 ohm, and this is 9 volt comma 6 ohm. So what I can do, it's a V is equals to I into R. My I current, it's a 9 divided by 30 ampere multiplied by 24. This is 6 fours are, and this is 6 fives are. So this has gone. 9 fours are 36 by 5. It's a 7.2 volt. This is the voltage. That is what we are required. Yes. What was your answer? Is it same? Great. Let's have a look to the next question. If the external resistance A is equal to internal resistance of a cell of EMF E, the potential difference across its terminal. Yes, they have given that external resistance and internal resistance are the same. So if they are same, current will be I is equals to E divided by R plus R. Now R and R are equal, so it's a E divided by 2R. This is the current that must be flow through the circuit. Now potential difference across the terminals, this is V is equals to E minus of IR. This is E minus I is equals to E by 2R multiplied by R. This has gone. E minus E by 2, it's an E by 2. Did it? Great job. This question requires approx 30 seconds only. Yes, so your brain should work like a bullet. As soon as question arises, it should start working and get the answer. This is what we require while we are attempting in competitive examinations. Yes, let's look at this question. Check the time and start doing it. What is given? It is 2 cells are there. The EMF are 2 volt and 6 volt. They are having an internal resistance of 0.25 and 1 ohm, and these two are connected in parallel. What we require? We require the terminal voltage. Okay, how could I get it? First, let's look at the structure. It's a 2 volt and its internal resistance, it's a 0.25. One more supply, it's a 6 volt, and its internal resistance, it is of 1 ohm, and these two are connected in parallel. Let's suppose here it's an R. What do you require? It's an E equivalent, that is equals to E1 R2 plus E2 R1 divide by R1 plus R2. So that should be is equals to, this is 2 multiplied by 1 plus 6 multiplied by 0.25, it's a 1 by 4 divide by 0.25 plus 1, it's a 1.25. So this is equals to 2 plus 6 by 4, 6 divided by 4, it's a 1.5 divide by 1.25. So this E equivalent can be written as 2 plus 1.5. This 2 plus 1.5, it's a 3.5 divide by 1.25. Yes, it's a 35 divide by 10 multiplied by 125 divided by 100. This has been gone, and this is 7 5 this is 25 5. So this has gone. This is 70 divided by 25. I hope you can solve this, and it would be the answer. Yes, it takes 1 minute to solve the answer. Yes, ready for the next question? Ready? Yes, our target would be less than 50 seconds. Let's have a look. What is question? It's a 4 cells, each of EMF 2 volt and internal resistance of 0.6 ohm are connected in parallel to a bulb of a resistance 9.85 ohm. Then the current in the bulb. Okay. So the situation something like this: first, second, third, and fourth. This is 2 volt and zero point 0.6. Each one is of same. And what you required to find out the current in this resistance. They have not said the resistance, they have said it bulb. Okay, it is one or other way. It's to calculate the answer. So what can we do? It's an I is equals to N into E divided by N into R plus external resistance. Total number of cells, how many? It's a four cells are required. Each cell is of 2 volt. Divide by internal resistance is of 0.6. So this is 4 into 0.6 plus 9.85. So this is equals to 4 to 8 divided by 4 into 0.6. It's a 0.24 plus 9.85. Yes, this is 8 divided by 4 into 0.6 plus 9.85. So this is the current can be calculated as I is equals to 8 divided by 9.85 plus 0.24. This is equals to 8 divided by approximately, this is 85, this is 25. So this is 85 plus 15, it's a 10 complete, and 10 more, it's a approximately 10.10. Yes, so you can solve this and get the answer, approximate answer. It's a 13 ampere. I hope these things are clear. Is it clear? Great. So can you do this kind of questions? Can you? This all are the questions that has been asked, because these are the questions of same pattern that has been asked in the previous year asked questions. Even we are going to have the sessions of the previous year asked questions, but this question even are on the same track, on the parallel track of the questions that has been asked. So let's have this question. A battery has 4 cells in parallel, each has an EMF of 1.5 volt and internal resistance of 0.8 ohm. The current delivered by it to a load of 2.8 ohm. This is the same question. Let's have a look. It's a 1.5 volt. We are having a 4 cells, 1 2 3 4, and it has been connected with external resistance of 2.8 ohm. So what I can have, it's a I is equals to NE divided by N into R plus R. So this is equals to 4 multiplied by 1.5 divide by 4 into 0.8 plus R. It's a 2.8. Just solve this and find out the answer. It's in 13 ampere. Yes, I hope you can do it. Can you do this? Are you sure? Can it be done? Great. Let's look at the next question. The internal resistance of a cell of EMF 1.5 volt, if it can deliver a maximum current, for maximum current, this is the relation I max is equals to E by R. EMF, it is of 1.5 volt. R, that I don't know. Now I want to calculate an I max. This is of 3 ampere. So this is the situation. 3 equals to 1.5 by R, and R is equals to 1.5 divided by 3. It's a 1 by 2, which is 0.5 ohm. That's it. 20 seconds questions. Yes. So is it easier to get it done? Is it easy to get it done? Are you sure? Can it be done? Sure? Okay, let's have a look to the next question. In the given circuit, the current is we require to find out the current. Now let's have a look that this is the 10 volt battery, this is the 5 volt battery. So current will be drawing from the 10 volt and it is moving in this condition, this direction. So first thing, whether these two cells are connected in series or in parallel. As current passing through both the cells are same, that means these two cells are connected in series. So what is E equivalent? Now let's look at here. A positive terminal of this battery has been connected with the positive terminal of the second battery. So this is the case of E1 minus of E2. So it would be a 10 minus of 5, which is equals to a 5 volt. Now find out the current. It's a I is equals to E equivalent divide by resistance of 2 ohm, and 1. It's a 2 plus 2 plus 1. The E equivalent, it's a 5 volt, divide by 2 plus 2 4, 4 plus 1 5. It's a 5 volt divide by 5 ohm. So this is equals to 5 by 5, which is 1 ampere. One more thing, 1 ampere having two options, but as this is the battery which will dominate, so the current will pass from A to B. This is the right answer. So 1 ampere and from A to B through E. I hope these things are clear. Is it? So current is moving in this direction because it has mentioned through E. Is it clear? Is it? Can we done this? Can we? Great. Next question. Look at this. What the question says. It says a cell of EMF E is connected across a resistance R and the potential difference between the terminals of the cell is found to be V. The internal resistance of the cell is, we need to find out the internal resistance. So what I can write is V is equals to I into R. Yes, and I know that I is equals to E divided by R plus R. So let's replace the value of I. It's a V is equals to E divided by R plus R multiplied by R. Now let's just divide this. That is the R plus R on this side divide by R, that should be is equals to V on this side and this people on this side. So this is R plus R divided by R, which is equals to E by V. Now let's just divide this R divided by R, which is 1, plus R divided by R, here it is equals to E by V. So R by R could be written as this is E by V minus of 1. So this can be simplified as this is E minus of V divided by V, and R can be written as E minus V by V into R. This is the relation which you must remember. This is very important question, very important. Yes, this is the internal resistance. When you need to find out the internal resistance of a cell, you have been given the potential difference, you have been given the EMF, but you have been not provided current through it. And when this is the situation, you need to find it out. Either you need to solve this every time, or you just remember it, put up the value and get it done within seconds. Yes, so all those students who are specifically medical aspirants, please remember this, because we are having only 1 minute to solve this question. Yes, so every time it is not possible to solve this, you just remember this: R is equals to E minus V divided by V multiplied by R, and things will be done. That's it. Great. So ready for the next question? Are you ready? Let's have a look. What the question says it is when two equal cells are connected either in series or in parallel across 2 ohm resistance, they send the same current through it. The internal resistance of each cell is. Do you remember this question? It was the first question of our this session. Yes, that's why I have written this. Two cells are connected either in series. When they are connected in series, it is E divided by 2R plus R. And when these two cells are connected in parallel, it's E divided by when two cells, because it is a 2E, divide by R by 2 plus R. What they want? They want the same current will be passed. So they says I in series is equals to I in parallel. So you can just equate this. Here it is 2E divided by R plus 2R is equals to E divided by R plus R by 2, and get it done. I hope this is clear. Even you might get this. Did you get this? Are you sure? Are you? Great. Let's find it out. The next question, again very important question, very important. Let's have a look. What does it says? It says two cells of same EMF are in series with an external resistance R, and the internal resistance R1 is greater than R2. It is something like this. This is first cell, this is second cell, and they are connected with an external resistance R. So this is E1, this is R1, this is E2, this is R2. They said that R1 is greater than R2. Okay, great. So this is the situation. The potential difference across the first cell is found to be 0, then the value of R. Okay, so what do you want? You want that potential difference across this. It is the first cell. If this is found to be 0, I require value of the resistance. So first what I can do is, let me calculate the value of an I. The two cells of same EMF, that is I equals to E1 plus E2, but they are same, that's why I can write it's a 2E divided by R plus R1 plus R2. Yes, this is the current that is being passed through this circuit. This is the current I, which is equals to 2E divided by R plus R1 plus R2. Now they mention that potential difference across the first cell is found to be 0. If voltage given across first cell is 0, then I can write like this: V is equals to E minus of IR. If I can write like this, it is V is equals to E minus of IR, and then I can put up the value that V would be equals to 0. This is E minus I into R. This is R1 multiplied by I. The I would be R1 into 2E divided by R plus R1 plus R2. So if I solve this, what I can have is resistance R is equals to R1 minus R2. This is the answer. I hope you can solve this. This E has gone, and this R1 plus R2 plus R, this is equals to 2R1. Let's pass it on this side. It's a 2R1 minus of R1 minus of R2, so I can easily calculate R, which is of R1 minus R2. Is it clear? Is it? Even this is one of the favorite question of examiners. Please remember this. It's an R is equals to R1 minus R2. Is it clear? Is it? So can we do this kind of questions? Is it possible within time frame? Is it possible within time frame that we are able to solve this? Are you sure? Let's look at this question. What they says that 3 cells of EMF 1.5 volt are first connected in series and then in parallel to an external resistance. The current obtained in the two cases are respectively 1 ampere and 0.36 ampere. Calculate the external resistance. So when they are connected in series, a situation may be something like this. It's a first, second and third, and this is connected with the external resistance R. This is E comma R, E comma R, and E comma R. Yes. So I can be written as 3E divided by R plus 3R, and when it has been connected through in a series, the current was 1 ampere. So this is 1 equals to 3 into 1.5 volt divided by R plus 3R. This is the situation when they are connected in series. Now when they are connected in parallel, a situation would be something like this. It's a first, second, and third, and this is connected with external resistance R. This is E comma R, this is E comma R, this is E comma R. The E equivalent will be remain the same because it's an identical cells, and my R equivalent would be equals to R by 3. So what is it? It's an I is equals to E divided by R plus R by 3, and the current, now the current is 0.36 ampere. So it is a 0.36, which is equals to 1.5 divided by R plus R by 3. Now we have two relations and we have two unknowns. Get it done. This would be the answer. Yes. Did you understand this? Any query? Any concern? No? Great. Let's have a look to the next question. What does it says? It says that cell of each EMF 2 volt are connected in series. Among them, if 3 cells are connected wrongly, yes, then effective EMF of the combination is. What does it says? It's a cells of each EMF. Maybe something is missing. Probably it is a 6 cells of each of EMF 2 volt. Let me check. When we connect cells wrongly, what we can have, it's an E equivalent is equals to N minus of 2M multiplied by E, and total number of connected cells properly is N. N is the total number of cells. So total number of cells, and M is the wrongly connected cells. This is wrongly connected cells. Yes, this here it might be 18 cells. So it might yes, let it take an 18 cells. So total 18 cells are there, minus of 2 into 3 multiplied by each cell is of 2 volt. So this is 18 minus 6, which is of 12 into 2. It's a 24 volt. Yes, so if I have taken 18 cells, this was not the answer and this would be the answer. I hope this is clear. But you must remember this. E equivalent is equals to N minus 2M into E. Is it clear? Is it? Yes. Do remember this thing as well, that what is N and what is M. Yes. So let's move to the next question. What does it says? It says that after the external resistance of a circuit has been increased to 5 times, the voltage across the battery terminal increased from 10 volt to 30 volt, and I need to find out the EMF of the battery. What does it say? After the external resistance of a circuit has been increased to 5 times, the voltage across the battery terminals increases. Voltage across the battery terminals increases from 10 volt to 30 volt. Then the EMF of the battery is, okay, so what I can do, it's a V is equals to I into R. I can be replaced as this is E divided by R plus R multiplied by R. Now what they says, it's initially voltage was 10 volt, so then 10 is equals to, we don't know even the EMF, divide by initially the resistance for R, internal resistance for R, and this is R. This might be the relation number 1. And the second relation, it's in 30 is equals to E divided by my external resistance has been changed to 5 times the initial value. It's an now it's a 5R plus R multiplied by R. This is relation number 2. Initially it was the 10 volt. This is the relation 1 and this is the relation number 2. I hope these things are clear. Is it clear? Yes. So this is relation number 1, this is relation number 1, this is relation number 2. Solve this and you will find that EMF of the cell would be a 60 volt by solving this 1 and 2. I hope those things are clear. Is it clear? Great. Next question is a cell of EMF 6 volt and resistance 1 ohm is connected to 9 ohm bulb. The percentage of energy released by the cell, which is useful. Even indirectly they want to ask what is the efficiency of the cell. Now what is efficiency? When we were in the last class, we have derived the relation for the efficiency. Efficiency is always about an output divided by input. Now what is output? It's in V. What is input? It's in E. So what is output? It's an I into R. And what is E? It's an I into bracket R plus R. So it is just the ratio of the terminal voltage to the EMF of a cell. It's a V by E. So useful energy which is released by cell, if I cancel this I, it's a R divided by R plus R. Now what is the value of R? External resistance, it's a 9 ohm, and internal resistance, it's a 1 ohm. 9 plus 1, 10. So this is 9 by 10 into 100, which is 90%. Yes, did you get it? Did you remember this? Do you? That efficiency of a cell can be written as V by E. If not, then you need to revise the previous lecture one more time. Yes, please take a note of each and everything that has been taught in this classes. This is very essential. Our syllabus is lengthier, but we cannot miss even a very small thing. That's why I try to cover as many theory as well as many application as possible. But this is simply not enough unless and until you are supposed to do it. So please do it, please. It's an humble request. Please get it done and things will be better, your numbers will be better, and you will get whatever you want. Let's have a look to the next question. What does it says? It says that two cells of EMF 3 volt and 5 volt and their internal resistance R1 and R2 respectively are in series with an external resistance of R. If the potential drop across, it's a potential difference across first cell is 0, then the R. It is the same question that we did in the 2 to 3 questions before. The situation would be this is 5 volt, this is 3 volt, and this is of 5 volt. This is resistance R1, this is resistance R2, and this has been connected with an external resistance of R. So current would be equals to 3 plus 5, which is equals to 8 divided by R1 plus R2 plus R. What we know that potential difference across first cell, this is declared as a 0. So this is equals to V is equals to E minus of I into R1, and this has been 0. So this is 3 is equals to I into R1, and I have replaced the value of I. It's an 8 divided by R1 plus R2 plus R. So if I solve this, I am having this, that external resistance R can be written as 5R1 minus of 3R2 divided by 3. Is it clear? Is it? So can you do this? Can you? Are you sure? Let's have a look to the next question. What does it says? It's an 3 sets of cells are connected in parallel and each set is having six cells in series, and this arrangement is connected to the bulb of resistance 3 ohm. If EMF of each cell is 2 volt and internal resistance is of 1 ohm, then the current through bulb. Yes. What is situation? Read the data one more time. You might get an idea that what examiner wants. Read the data one more time. It is essential. Read it. Okay. Let me try it. 3 sets of cells are there, and each set having 6 cells in series. That means a situation is something like this. It's a first, second, third, 4, 5 and 6. This is first set. Such like one more set is there. One more set like this. It's a 3 sets. This is first, this is second, and this is 3. This 3 sets are there, and each set is having a 6 cells, and EMF of each cell is 2 volt. So if it's a 2 volt, 2 volt, 2 volt, 2 volt, 2 volt, and something like this. Same is the case for everyone. So if I solve only this line, it's a 2 6 12 volt, and their internal resistance, what is it? It's a 1 ohm. That means this is of 6 ohm. One more line, it's a 12 volt and 6 ohm. One more line, it's a 12 volt and 6 ohm. Yes, and bulb works as an external resistance, and external resistance is of 3 ohm. So this is 3 ohm. This is ohm. Yes. So I need to calculate current through this. Let me do this. So it's a 12 volt and 6 ohm. Again it's a 12 volt and 6 ohm. This is 12 volt and 6 ohm. This is 12, 6, 12, 6, 12, 6, and external resistance which is behaves as a bulb, it's a 3 ohm. So I need to find out the current that has been passed through here. So first I need to find out E equivalent of this combination. I required E equivalent of this combination. How can I do this? So their E equivalent will be equals to 12 volt. How could I get it? Because all these are identical cells, and when cells are connected in parallel, then the identical value, when for the identical cells, E equivalent would be the same as any one of the cells, but their R equivalent will be equals to 6 divided by 3, which should be of 2 ohm. So current is E equivalent divided by R equivalent plus external resistance R. This E equivalent would be of 12 volt, R equivalent would be of 2 ohm, and R is of 3. It's a 12 divided by 5, and 12 divided by 5, it's a 2.4. 24 5s are 120. Yes, it's a 2.4 ampere of current that must be passing through here. I hope these things are clear. Is it crystal clear? Is it? Okay. Do you want to learn theory of this? Theory of this topic? Do you? Let's have a look. This is what we call as it is the mixed grouping of cells. Let's suppose a one cell, another, third, fourth, fifth, and such as n cells are connected. This is E comma R, E comma R, E comma R, E comma R, and so on in a one row. Like this, there are m number of rows are there. There are m number of sets. something like this. And this is being connected with the external resistance R. So each line, I can say each set contains n identical cells, and there are total m sets. Yes, so each set having n number of cells, and there are total m number of cells. What I want current to be find it out. So what can I do? I request you guys to please draw the circuit in your book. Please draw the circuit and try to get it done. Each one is of identical E and onwards. So this can be written as that this is NE, and their internal resistance would be of NR. Same way this is of NE and NR, such as m number of lines are there. This is NE, this is NR, this is m number of lines, and this is the external resistance of R. So this is, look at this, each one is of identical cell, so their equivalent EMF would remain the same, but their internal resistance changes, which is an NR divided by M divided by external resistance R. So I can write like this, it's I is equals to NE divided by NR by M plus R. I hope these things are clear. If you want, you can solve this as this is NE divided by NR plus MR multiplied by M, which is N into M into E divided by NR plus MR. I hope this is clear. Is it? So even if you remember this theory, you remember this formula, you can go with this, that there are three sets of cells. That means we are having M as a 3, and each set is having a 6 cells. That means N is 6, and R external is of 3, and then put up the value and get it done. Yes, so please remember this. Yes, are you sure? So can it be done? Can it be? Great. Let's wind it up this session over here. Yes, in this session we were discussing the practical applications of cells in when they are connected in series and parallel. So this is all about the electric cells and the combination of the cells. Please do as many questions as possible from your side. Yes, because practice only can save us. Thank you. Have a good day. Take care. Bye bye.